Today we are going to understand performance metrics in scalable systems. When we hear the word scalability, we usually think about handling more users or more traffic, right? But scalability is not only about handling load. A good scalable system should also stay fast and responsive while traffic increases. There are three important metrics we need to know. First one is throughput, which means how much work the system can handle, and the second one is latency, which means how long a request takes to respond, and the third one is percentile, which help us to understand the real user experience during slowdowns. Let's start with throughput. Throughput means the amount of work completed in a certain time. In backend system, it is usually measured as request per second or RPS. For example, if a server handles 5000 requests every second, then its throughput is 5000 RPS. Higher throughput means the system can support more users, but throughput is always affected by bottlenecks. Like sometimes the CPU becomes overloaded or sometimes the database becomes very slow. To improve throughput, companies add more servers or use caching and optimize slow operations. But high throughput alone is not enough because user doesn't feel throughput directly, but they can feel latency. Latency is the time a system takes to respond to a request, and in simple terms, it is the waiting time experienced by the user. Even if a system can handle millions of requests, user may still feel unhappy if the response is slow. Latency can happen due to application processing, database queries, network calls, or third-party services. When all these delays combine, the total response time increases. That is why engineers always try to reduce latency and improve system performance because faster systems provide a smoother and better user experience. One important thing to remember is that latency is not always consistent. Some requests are completed quickly, while others become slower because of high traffic or temporary system issues. That is why measuring only average latency is not enough. Instead, companies use percentiles to better understand user experience. P50 represents the typical user experience, and P95 means that 95% of requests are completed faster than that value. And P99 represents the slowest request, also known as tail latency. Tail latency is very important because it helps engineers identify the worst user experience that average values often hide. At a small scale, 1% may seem like a very small number, but in large systems, even 1% can affect thousands of users. That is why companies carefully monitor P95 and P99 latency. Even small delays can make a difference. A delay of just few hundred milliseconds can make users feel that the application is slow. Most users may get a smooth experience at P50. Some users may notice delays at P95. And users affected by P99 latency may refresh the page or retry the request or even stop using the application. So the main goal is not to make the system fast, but also to make the performance consistent for almost all users. So the final takeaway is simple. A scalable system needs both high throughput and low latency. Engineers continuously monitor important metrics like throughput, latency to understand system performance. They identify bottlenecks and improve the slow part of the system. To keep the system fast and stable, they use techniques like caching, load balancing, queues, and horizontal scaling. They also test the system under high traffic before real users start using it. Because scalability is not only about handling more traffic, it is about handling more traffic while still keeping the system fast, smooth, and reliable.